good morning to all of you. Today onwards we discuss about the evening shift question paper which is conducted on 23rd 1 2025. First we discuss about first year concepts. Okay, first. What is the first question? The energy of a system is given as Et is equal to alpha cube into e power minus beta t, where t is the time and beta is something. The error in the measurement of alpha and t are 1.2 and 1.6 respectively. At time t is equal to 5 seconds, maximum percentage error in the energy is. So what is given? Given energy. It is a function of time. That means with respect to time, energy is changes. How it is changes? Alpha cube into e power minus beta t. You want to calculate maximum percentage error in the measurement of energy is, you can take log ln E is equal to 3 into log alpha minus beta t. Okay. You want to calculate maximum percentage error. That means dE by E maximum is equal to 3 into d alpha by alpha minus d beta by beta, beta into dt by t into t. Okay, according to logarithm function. So dE by E, this is what to calculate, 3 into d alpha by alpha. The change in, that means the error in the measurement of alpha is what? 1.2%. 3 into 1.2. Okay, minus beta. Beta is constant. What is that? 0.3 into the error in the measurement of time is equal to what? 1.6. 1.6 into t is calculated at time t is equal to what? 5 seconds. So 3.6 minus 1.5, isn't it, into 1.6? It is equal to 2.4. 2.4 plus. Okay, what is that? Which is equal to 3.6. Then you got 6%. Okay, right, that's it.
The second question, match list 1 with list 2. Okay, what are given in list 1? Permeability of free space, magnetic field, magnetic momentum, torsional constant, and their dimension formulas are given. Okay, now we discuss compare list 1 with list 2. Okay, this is list 2. Okay, this is list 1, this is list 2. Compare these two. Okay, the solution of this question to see. What is it? First one is permeability. Permeability. Okay, permeability is equal to what? Mu naught. Okay, which is obtained from, permeability is obtained from, what is that? Ampere circuit law. B is equal to what? Mu naught N I by 2 into R. That implies mu naught is equal to B into R by N into I. Here to see, here B is equal to what? Magnetic field intensity. Magnetic field intensity is equal to what? F by M. You know, F is equal to what? M L T power minus 2. M is equal to what? Magnetic pole strength. It is nothing but ampere meter. What is it? Ampere meter. So ampere is current A, meter is L. So this L is cancelled. M T power minus 2 A power minus 1. So you may replace B by M T power minus 2 A power minus 1, this one. So what is that? M T power minus 2 A power minus 1 into L, because R is equal to distance is L. Current I is equal to what? A. So you may simplify it. M T power minus 2. What is it? M T power minus 2. Or means M L T power minus 2. This, when this A go to the numerator, it is nothing but what I say? A power minus 2. So M L T power minus 2, this one. So permeability of free space is this one. Okay, next one is called magnetic field. Already we can discuss it. M T power minus 2 A power minus 1. M T power minus 2 A power minus 1. Sorry, this thing. Magnetic field. Okay, next see magnetic moment. Magnetic moment M is equal to what? Pole strength into length of the bar magnet. Pole strength equal to what? Ampere meter. Length is equal to meter. That implies what? Ampere meter square. That implies A into L square. This thing. Okay, next torsional constant. torsional constant theta is equal to from moving car galvanometer C theta is equal to torque tau. That implies torsional constant C is equal to what? Torque by theta. Theta is what? Angular displacement. It is doesn't have any dimension formula. So torque is equal to what? It's nothing but work ml square t power minus 2. That's it. So what is the remaining ml square t power minus 2? So this is the answer for this question, right? The third question, a ball having kinetic energy Ke is projected at an angle 60 degree from the horizontal. What will be the kinetic energy of ball at the highest point? To see initial kinetic energy, first is what is that? Initial kinetic energy is equal to K. Suppose for example, say call K1. Now it is what happened, projected at an angle 60 degree with the horizontal. If theta is equal to what? 60. So actually this is a body projected with some velocity u, that makes an angle 60 degrees. So what happened, the body is moved against the gravity, so its velocity is gradually decreases and becomes zero of its maximum height. But at that highest point it having some velocity, that is nothing but horizontal component of velocity. What is that? U cos theta. So at highest point of its flight, velocity v is equal to what? U cos theta. So what is that? U is equal to, it is any given? No, nothing is given. So u into cos 60. So u into what? 1 by 2. That implied what? U by 2. Therefore kinetic energy at highest point, say K2. Therefore what is asking? K1 by K2 is equal to, K1 is equal to what? Half mu square, initial kinetic energy before it projection, which is equal to what? Half mu square. After projecting some velocity of m, u cos theta square, which is equal to what? Which is equal to half of cancel, cancel, then remaining u square by u cos theta whole square, which is equal to what? U square by u by 2. That means u square by 4. U is equal to, so u cos theta whole square means what? U square by 4. Then this is cancel, equal to what? 4. That implies K2 is equal to K by 4. So this is the answer for this question, right? The fourth question, a circular disc of radius r meter and mass m kg is rotating about the axis perpendicular to the disc. See a circular disc, suppose this is a circular disc of radius r, its radius is equal to what? R, and its mass is m, is rotating about the axis perpendicular to the disc, which is rotating about an axis. This is the axis, rotating about this axis. Now what happened? An external torque is applied to the disc. Now what I say, I would like to apply tangentially a force which causes rotate the body. So the force is called torque. This torque is applied such that that means here where theta is the angle position of the rotating disc as a function of time t. How much power is delivered? So power is asking, when a body in rotatory motion, the power P is equal to what? Torque into omega. In translatory motion, power P is equal to what? Force into velocity. That is in translatory, that means linear motion. Same kind of role played by rotatory motion is called torque, that means called force is analogous of torque in rotatory motion. Similarly, omega is the rotation analogous of velocity in linear motion. So power equal to what? Torque tau into omega. Tau is equal to what? I into alpha into omega. Here I is equal to what? Moment of inertia. Moment of inertia. Here the disk is rotating about an axis perpendicular to its plane. So the moment of inertia is equal to what? M r square by 2. What is it? M r square by 2. Alpha is equal to angular acceleration. Angular acceleration. Okay, which is equal to what? D omega by dt or d square theta by dt square. Here omega is equal to what? Angular velocity. Angular velocity, which is equal to what? Rate of change of linear angular displacement. But here to see, here theta is the angular position change with respect to time, which is changes like this equation. So given angular position with respect to time t is equal to 5 t square minus 8t. So you want to calculate angular velocity, differentiate it, that means d theta by dt, that means 5 into 2 into t minus 8 into 1, that means 10t minus 8 is the angular velocity. Similarly, angular acceleration alpha is equal to what? D omega by dt, that means again you should differentiate it, then you get 10 into 1 minus 0 equal to what? 10. So omega alpha is equal to 10, omega is equal to this one. Okay, therefore power generated P is equal to I m r square by 2 into alpha, alpha is get 10 into 10 into omega, omega is equal to what? Angular velocity 10t minus 8, but you can calculate when time t is equal to 2. If t is equal to 2, that implies omega is equal to 10 into 2 minus 8, 20 minus 8 is equal to what? 12. So into 12, omega is equal to 12, 2 1 ja, 2 5 ja. Okay, that means 60 m r square. So this is the answer for this question. Okay, right. Right. The fifth question, water flows in a horizontal pipe whose one end is closed with a valve. The reading of the pressure gauge attached to the pipe is P1. The pressure reading of the pressure gauge falls to P2 when the valve is opened. Okay. The speed of the water flowing in the pipe is proportional to how dependent? Okay, the speed of water flow through the given pipe with respect to the pressure difference between the two ends when it is once closed, once it is open. Okay, you know this is solved based on Bernoulli's theorem. So Bernoulli's, from Bernoulli's theorem. What is the Bernoulli's theorem? When a non-viscous, incompressible, okay, irrotational, that kind of fluid is called ideal fluid. So when ideal fluid is flow through a pipe of flow, okay, the pressure, what is that? The pressure, the kinetic energy, the gravitational energy, that means pressure head, kinetic head and gravitational head remains constant everywhere in its motion. That means in every same at every point in its motion. So it may write P square by 2 or simply say called pressure head P. What is the pressure? Plus half rho into V square is equal to what? Constant. Here I don't want to mention about position potential because both ends are not tell about this question. So I would like to take both ends of this pipe at the same height from the ground. Okay, that's why. So here to say initially pressure when it is closed P1. So at that instant rho into velocity equal to what? 0, isn't it? Next pressure changes, okay, from P1 to P2, okay, while its okay velocity becomes what? V square, isn't it? Right. Now to see, therefore P1 plus 0 is equal to P2 plus half rho into V square. You know this P2 is brought into this side, that means P1 minus P2 is equal to half into rho into V square. That implies rho V square is equal to 2 into P1 minus P2, isn't it? But here what is asking? The speed of the water flowing in the pipe is proportional to how depend. That means speed of the pipe V square is proportional to what is that? P1 minus P2. That implies V is proportional to what? Root over P1 minus P2. So this is the answer for this question. Okay, right. The sixth question, if a satellite orbiting the earth is 9 times closer to the earth than the moon, okay, what is the time period of rotation of the satellite? Given rotational time period of moon is equal to 27 days and rotational attraction between the satellite and the moon is what? Neglected. So what is given? If a satellite is orbiting the earth, for example, to see, this is the earth, okay, around this earth, okay, the moon is supposed to be orbiting, okay. So what is the distance between earth and moon is called r, but satellite is revolving. Another one is called, this is a satellite which is revolve, but actually this is the satellite is at a distance what? 9 times closer. That means what? R by 9. R by what? 9. So given R1 is equal to R, R2 is equal to what? R by 9. So R1 is equal to R moon. So this is taken time T1 is equal to 27 days to revolve the earth. So what is the time taken by the satellite to revolve the earth? This is asking. So from Kepler's third law, what is Kepler's third law? T square proportional to what? R cube. Square of the time period is directly proportional to cube of the semi major axis. So T square proportional to R cube. Therefore T1 by T2 whole square is equal to R1 by R2 whole cube. Okay, T1 is given 27, T2 is required 27 by 2 is equal to R by 9. This R is cancelled, this is 2, that implies 27 by T2 whole square is equal to 9 power 3, isn't it? So that implies T2 is equal to, the T2 is equal to, it may write like this, otherwise simply say call 27 means what? 3 cube whole square by T square, T2 square is equal to 9 cube. What is that? 9 cube. That implies T2 is equal to, it is nothing but what is a 6. That means when you simplifying this thing, you get 27 by 27 equal to what? 1 day. Okay, that's it. The seventh question, water of mass m gram is slowly heated to increase the temperature from T1 to T2. Okay, the change in entropy of water. Okay, to see a water of mass, suppose in this enclosure a mass, water is there. Okay, its mass is equal to what? M. Initially it is a temperature say called T initial, Ti, isn't it? So now what happened? This is slowly heated, that is given. Slowly heated, that means some amount of heat is supplied to it, which causes, okay, the temperature of this water changes from Ti initial to T final. Okay, the change in entropy, while the temperature changes from T1 to initial to final, some changes are happened in water molecule, its configuration, its energy, whatever may be it. Okay, so some disaster may be occurred, causes its temperature changes from T1 to T2, that means T initial to T final, initial temperature to final final temperature. So this disaster is nothing but what I say, entropy. Okay, whenever to see from you give heat, so that is called heat capacity, that supplied heat may be taken by the water, that is it is depends on its nature, it is called its specific heat. So the heat gained by a body due to rise in temperature from Ti to Tf is equal to, or dq is equal to m into s into dt, isn't it? Okay, but you know what is asking, change in entropy, what is that? Delta S is what? You know delta S is equal to what? Dq by T, dq by T. Here dq is equal to what? Ms dt by T, isn't it? Why? Because dq is equal to ms dt. but entropy, which is called what is a entropy. Okay, dq by t. Okay, so you want to calculate change in entropy. Okay, you should differentiate it. That implies delta S is equal to integral t initial to t final ms dt by t. Okay, that implies delta S is equal to mass is not changed, specific heat into is also a constant for that given substance into Ti integral Ti to Tf dt by T, isn't it? Isn't it? Here in the question itself, the specific heat, given specific heat of water equal to what? S. Here S is equal to what? That implies entropy delta S is equal to m into log. What is that? It is nothing but as a log T, limits Ti to Tf. Therefore, entropy delta S is equal to m into log Tf by Ti. Okay, this is the answer for this question. So, this is the entropy. Okay, that's it. The 8th question, this is a graph. Okay, it is a indicator diagram. Indicator diagram is nothing but graph drawn between pressure and volume. Okay, that is called an indicator diagram. Using this graph, okay, the work done by an ideal gas along the path A, B, C, D. Okay, so what is the total work done? Total work done by a gas along path, what is that? A, B, C, D is. Okay, what is that? W, A, B, C, D, which is equal to work done initially gas from reached A to B, that means work done A to B, plus work done by the gas from B to C, isn't it? Plus work done by the gas C to D, that is it. You can calculate work done A to B, B to C and C to D, then you get the total work done by the gas reached from its initial state A to final destination D. So, in thermodynamics, you know, work done by a gas, work done W is equal to what? P into V, pressure into volume, that is it, isn't it? Therefore, work done by the gas from A to B is equal to, what is the pressure at A? P naught. Okay, what is the pressure B? What is the pressure at B? Pressure at B, what is that? Pressure at B, P naught, it remains the same, but volume changes from 2 V naught to 3 V naught. That implies what? 3 V naught minus 2 V naught, which is equal to what? P naught into V naught. Next, work done by the gas from B to C. While C, here volume remains constant, but pressure changes from P naught to 2 P naught. So, change in pressure 2 P naught minus P naught into volume 3 into V naught, which is equal to what? 3 into 3 V naught into what? P naught, 3 V naught into P naught. But here to see, if there is no change in volume, then what happen? Work done equal to what? 0. Okay. Next, work done C to D, work done C to D. Here pressure remains constant. What is that pressure? 2 P naught into V naught, initial 3 V naught, final V, that implies 3 V naught, final means final minus initial, final equal to what? V naught minus 3 into V naught, isn't it? Okay, pressure final, this is equal to 2 P naught, yes, it is nothing but 2 P naught, but it is in reverse order. So, it is nothing but what I say, this thing. So, minus minus plus, so minus 2 P naught, okay, minus 2 P naught into V naught, 3 V naught minus V, 3 V naught, it is nothing but what I say, plus, that means what? Final minus initial, this thing minus this thing. So, you get 2 into V naught, that implies what? Minus 4 P naught V naught. Therefore, total work done W A B C D, which is equal to AB is equal to what? P naught V naught plus 0 plus minus 4 P naught into V naught, isn't it? So, we get P naught V naught minus 4 P naught V naught equal to what? Minus 3 P naught into V naught. So, this is answer for this question, right? Right, the ninth question, a massless spring gets elongated by amount x1 under tension 5 Newton. Its elongation is x2 under the tension 7 Newton. For the elongation of 5x1 minus 2x2, the tension in the spring will be, to see, a massless spring gets elongated by an amount x1 under tension 5 Newton. That means tension force is directly proportional to elongation produced in the string, but actually this is opposite, but you can take this is here negative sign represent opposite. That implies it may write that implies F is equal to K into X in magnitude, isn't it? Therefore, K into x1 is given while elongation is x1, which is equal to what? 5 Newton. Next, similar same spring under tension 7 Newton, elongation equal to what? X2. But in this question he is asking 5x1 minus 2x2. So, it may write K of x1 minus K of here to 6 same spring. So, it may write like this, what is that? K into 5x1 minus K into 2x2 is equal to 5 into kx1 minus 2 into kx2, but kx1 is equal to what? 5 Newton. 5 into kx1 is equal to what? 5 minus 2 into kx2 is equal to what? 7. That means 25 minus 14, 25 minus 14 equal to what? 11 Newton. That is it. The 10th question, an air bubble of radius 1 millimeter is observed at a depth of 20 centimeter below the free surface of a liquid having surface tension 0.095 joule per meter square and density 10 cube kg per meter cube. The difference between pressure inside the bubble and atmospheric pressure is, to see, this is the open surface, okay, this is the bottom of this lake, something, whatever may be the given thing. An air bubble of radius, or what is that? This is an air bubble of radius is something, okay, is observed at a depth of, how much depth it is there? 20 centimeter from the surface of the liquid having surface tension is something, okay. You know the pressure at open surface equal to what? P naught, okay, but in depth the pressure is a call inside Pn. He is asking what is the difference in pressure between inside and outside, okay. That means delta P is equal to P in minus P out, because at the depth there is a maximum pressure. So, P inside is nothing but what is a P naught plus rho GH, you know very well. In addition to that, this is an air bubble. So, what is the pressure inside it? 2T by R. So, this is the total pressure on this air bubble when it is at depth of 20 centimeter below the free surface at P naught pressure is there. So, the difference in pressure, what is that? P in minus P naught. P in equal to what? P naught plus rho GH plus 2T by R minus pressure at open top, that means P naught. This P naught cancel. Therefore, difference in pressure equal to what? Rho GH plus 2T by R. Rho is the density. What is the density is given? 10 cube. That means 1000 into G already given. What is that? 10. H 20 centimeter means what? 20 by 100. 20 power 20 in 10 power minus 2 plus 2 into. What is the surface tension of this given? 0.095 by R. R is the radius of the air bubble. 1 millimeter means what? 1000. 10 power minus 3. isn't it? 10 power minus, that means 10 power minus 3. Okay, it may write 2 zeros are cancel. This is nothing but 100 into 220, isn't it? 2000 plus 196, isn't it? 196. So 2196. What is the 2196? 2190. Sorry, 2190. Okay, this is the answer for this question. Okay, right. The 11th question, a satellite of mass. Okay, a satellite of mass m is equal to what? M by 2 is revolving around Earth in a circular orbit. Suppose this is Earth, around this Earth a satellite is supposed to be revolve. Its mass is equal to what? M by 2. Okay, it is at a height of r by 3. It is at a height of what? R by 3. So height, that means r is equal to what? R plus r by 3. That implies, you know, isn't it? R is the radius of the Earth, okay, and r by 3 is the height of the Earth. So total height above the surface, that means above the center of mass of the Earth is at r plus r by 3 equal to what? 3r plus r by 3 is equal to what? 4r by 3. Okay, so it is revolving. So what is its orbital velocity? Orbital velocity v naught equal to what? Root over g m by r equal to root over g into what? M is equal to m by 2, r is equal to what? 4 r by 3, which is equal to what? 3 g m by 8 r. This is the orbital velocity. Okay, the angular momentum of the satellite is angular momentum. Angular momentum L is equal to what? M v naught into r. M into mass into velocity into radius. Therefore, L is equal to m into v naught. What is the orbital velocity? Root over 3 g m by 8 r into r. What is the r? 4 r by 3. 4 r by 3. Therefore, L is equal to m into root over. When you go brought into the square root, what is the value? 16 r square. That means 48 g m r square by 9. 72 into r. Isn't it? 72 into r. Okay. Therefore, L is equal to under root 8 9, isn't it? So, m into 8 g m r by 9 into r, 9 into r. Okay. So, you get its value is equal to, therefore, compare it with this value. What is that? M into root over g m r by x, g m by x. So, this r is also cancelled. So, you get the value of x is equal to what? 3. Okay, right.